Hello and welcome to Excel Mathematics TV. In this lesson, we will learn how to solve multiplication equations. In solving this type of equation, we will use the inverse operation of multiplication. Let's get this lesson started. What is the inverse property of multiplication? It's division. So we will solve multiplication equations using division. Now, how are we going to do that? By dividing both sides by the same number. Also, that number should be the coefficient of the variable. The reason for that is to eliminate the coefficient and leave the variable isolated. That instruction is very easy. To master it fully, let's have some examples in solving multiplication equations. We will solve 5x equals 10, and we will check if our solution is correct. Let's use a model of the equation in this example. So we need to model the equation first to find the solution. This is how the model for 5x equals 10 looks like. We said earlier that we use division in solving multiplication equations. So we will divide the yellow counters and cups equally into 5 groups. If we're going to interpret it as an equation, it'll look something like this. Now to find the answer, we need to count how many yellow counters each group has. Let's count. There are 2 yellow counters in each group, and each has a corresponding cup. The cup represents the variable x. Thus, x is equal to 2. We are already sure that our answer is correct, but to be 100% sure, let's check if the solution to the equation is really x equals 2. So the given equation is 5x equals 10. To check our answer, all we need to do is substitute x equals 2 into the equation and simplifying it. After substituting, the equation becomes 5 times 2 equals 10. Then, what's next? We need to simplify the left side of the equation by multiplying 5 and 2. 5 times 2 is equal to 10. Then we'll have 10 equals 10. This is obviously true. Thus, our answer is correct and the solution is really 2. Let's have another example. We have negative 9x equals 72. First, we need to write down the given equation here. Previously, we used the model method. Now, for this example, we will solve it in a different way. We want x to be isolated on the left side of the equation, right? So, to start, we need to eliminate the numerical coefficient of x, which is negative 9. To do that, divide each side by negative 9. Just like this. Now let's simplify what's needed to solve the equation. Because negative 9 divided by negative 9 is equal to 1, and 72 divided by negative 9 is negative 8, our equation will be simplified to 1x equals negative 8. Remember, if the numerical coefficient of a variable is 1, then it's fine, even if we don't write it. So 1x is the same as x. And from there we can find the solution. That is x equals negative 8. Thus, our solution is negative 8. Are you getting the hang of solving multiplication equations so far? Because we will now solve an example which is harder than the previous ones. But don't worry, it's still pretty easy to solve. We will use the formula a equals b times h to find the base of a parallelogram illustrated here. Are you familiar with this formula? This is actually the formula for finding the area of a parallelogram. So we have one dimension given, and the area is indicated in the figure. We just need to write an equation using the formula a equals b times h and the given area and height. The area of the parallelogram is 54 feet squared, and its height is 6 feet. Substituting those two in the formula will give us the equation 54 equals b times 6. We want the variable or the unknown, b, to be on the left side of the equation, so we'll switch sides and apply the commutative property. Then the equation will become 6b equals 54. After that, we need to isolate b on the left side of the equation. We can do that by dividing both sides by 6. Just put 6 under each side of the equation to indicate division. Cancel 6, and 54 divided 6 is equal to 9. Then, b is equal to 9. That means that the base is 9 feet. The lesson about solving multiplication equations ends here. As always, don't forget what you've learned in this lesson and apply it when necessary. Thank you, and until next time.